A freshly isolated sample of 90Y was found to have an activity of 1.5 times 10 to the 5th disintegrations per minute at 1 o'clock p.m. on December 3rd, 2006. At 2:15 p.m. on December 17, 2006, its activity was measured again and found to be 4.0 times 10 to the 3rd disintegrations per minute. Calculate the half-life of 90Y. So we are asked to calculate the half-life of 90Y, and the half-life is related to the rate constant K. The rate constant can be calculated from the number of nuclei present at two different times. Since all radioactive decay processes have first-order rate laws, the decay rate is proportional to the amount of radioisotope at any time. So first off, the rate constant K will be calculated from the given amounts, then the half-life will be calculated from the rate constant. The equation that relates the number of nuclei at two different times to the rate constant is ln times n t over n o. Be sure not to confuse that little dash with a negative, is equal to negative kt. So what we have to do now is rearrange this equation to solve for k. So the new equation is going to be k is equal to ln nt over no over t. And that's going to be negative now. So T is time, K is the rate constant, NT is the number of nuclei at time T, and NO is the number of nuclei at time 0. And the half-life is related to the rate constant by the equation T 1/2 for half-life is equal to 0.693 over K, which is what we're going to calculate to find right now. So the time interval between December 3rd and December 17th is a total of 14 days, 1 hour, and 15 minutes. So we have to convert this all to minutes. So we find that over the course of those 2 or 3 weeks, an amount of 20,235 minutes have passed. And that's our time interval. So going back to solving for K, K is equal to ln 4.0 times 10 to the 3rd disintegrations per minute over 1.5 times 10 to the 5th disintegrations per minute over the amount of time that has passed, which is 20,235 minutes. And once we calculate this, we see that it equals 1.8 times 10 to the -4th minutes, -1. And now we can plug that in to calculate our half-life. So our half-life equation is T is equal to, T 1/2 is equal to 0.693 over 1.8 times 10 to the -4 minutes, -1. And that equals 3.9 times 10 to the 3rd minutes. And that is your half-life of the disintegrations.